Alright, so we're going to start out with the objective, and the objective here is that the student should be able to use double angle identities for sine, cosine, and tangent functions. And there are 5 different double angle identities, so I'm going to start by listing all of those. And the first is sine 2 theta equals 2 sine theta cosine theta. And number 2 is cosine 2 theta equals cosine squared theta minus sine squared theta. And number 3 is cosine 2 theta equals 2 cosine squared theta minus 1. And the fourth is cosine 2 theta equals 1 minus 2 sine squared theta. And for the fifth, we have tan 2 theta equals 2 tan theta over 1 minus tan squared theta. Okay, now that we have all of those away, I'm going to have to erase these because I don't have much room on this whiteboard, but those are the 5 double angle identities that we need to know. Sorry that I have to erase these, but I don't got a ton of room. Alright, this eraser sucks. Okay, so we're going to start with our first problem, and we're going to start with the right triangle here. Sorry, that was not a very good triangle. We'll start with A, B, C, and I need to fix this. Hold up. There we go. Alright, sorry about that. We're going to go with 3, 4, and 5. And since we're going to be trying to find cosine 2 of the angle ABC, we have to find cosine first, which would be 3 over 5 because of SOHCAHTOA. And we're going to start with that. So we will have cosine 2 theta equals cosine squared theta minus sine squared theta. And sine will be, what, 4 over 5? So we will have 3 over 5 squared, parentheses, minus 4 over 5 squared, which would leave us with 9 over 25 minus 16 over 25, which would leave us with negative 7 over 25. And that's about it for that problem. Okay, so we're going to move on to our next problem, but before we do that, I want to clear up the last one. And we had 3/5 originally, cosine equals 3/5, and then we ended up with negative 7 over 25. So if you want to know how that makes sense, you have to make it a double angle identity, you're going to have to use a unit circle to just use an example. And sine or cosine 3/5 would be around here, and then that next equation we got would be negative 7 over 25, which would be around this side, which would create that double angle identity. And we're going to move on to our next problem now. So, sorry, I already have it written down here. It's sine theta equals 2/3, and theta has its terminal side in the first quadrant. And our objective is to find the exact value for sine, cosine, and tangent. So we're going to start with sine 2 theta. That's what we're going to begin to find. So, but before we do that, we have to find cosine theta to get to sine 2 theta. So you're going to want to use sine 2 theta plus cosine 2 theta equals 1. And that would be 2/3 squared, parentheses, plus cosine 2 theta equals 1. And you're going to want to get this out of here. So that would be 4/9, and then you'd have to add 1, which would equate to 5/9. And let me write this out. Cosine theta equals 5/9. And to get rid of that, we want to square this and square this, get those square roots. And that would leave us with cosine squared theta equals square root 5/3. So we found cosine theta, so now we can move on to find sine 2 theta. And sine 2 theta equals 2 sine theta cosine theta. So that will leave us with 2 parentheses 2/3 and parentheses square root 5/3. So let me move up here, sorry. So that will leave us with the same term. We'll have the same terms over here. So 2/3 square root 5/3. So that'll leave us with 4/9, and then square root 5/9. So that will eventually lead to 4 square root 5/9. And that'll be our sine 2 theta. Alright, I need to start erasing some stuff because I don't got much room up here, but sorry, I gotta erase all this. So we found sine 2 theta. Now we're gonna go and find cosine 2 theta. Wow, this is not a good eraser. Alright, so I'll write the answer for sine 2 theta right here. We have 4 square root 5/9. So that's one of the answers we need. Then to find cosine 2 theta, we're going to want to, we already know cosine and sine, so we can use any identity. So I'm going to start with cosine 2 theta equals cosine squared theta minus sine squared theta. And from there we will have square root 5/3 squared minus 2/3 squared. And we're going to cancel, so we'll have 5. These squares will cancel, sorry. So we'll have 5/9 minus 4/9, because 2 times 2, 4, 3 times, or 2 squared, 4, 3 squared, 9. And then here, these cancel, 3 squared is 9 over here. So 5/9 minus 4/9 equals 1/9. And that'll be our answer for cosine 2 theta. So cosine 2 theta equals 1/9. Let me erase this and just write the answer for you. Sorry. Alright. So we'll have cosine 2 theta equals, what did we have? 1/9? Yeah. So it's the second answer we're looking for. And to find, well, our last one, tan 2 theta, we have the equation of tan theta sorry, that's not the equation. That's how you want to find tan theta. And then we'll have 2/3, since that's sine theta, over square root 5/3. And from there, we will end up with 2 square root 5/5. And now we can go ahead and find tan 2 theta. So we will have tan, and we will use the fifth identity from the beginning that I showed you guys, 2 tan theta over 1 minus 10 squared theta. And from there we will have 2, because we'll plug that in. We'll just plug the 10 theta into this. 2 square root 5 over 1 minus 2 square root 5 squared, which will end us with 4. We'll plug this. 4 square root 5 over 1, which is just 4 square root 5. Sorry, got a little crooked there. And so tan 2 theta equals 4 square root 5, and I'm going to erase this and write that final answer down up here. So we will have all 3 of the answers that we needed. Man, this eraser is not good. I'm sorry. So we've got 2 up here, and for the final, tan 2 theta equals 4 square root 5 over 1, which is just 4 square root 5. Sorry, could have left it like that. But so we got our objectives, got our 3 answers. Sine 2 theta equals 4 square root 5 over 9. Cosine 2 theta equals 1 over 9. And tangent 2 theta equals 4 square root 5 over 1. And that's about all we got. Goodbye.